Most AC voltmeters, ammeters, and wattmeters are designed to indicate the RMS value, not the peak value. If the meter does not state that it's intended to measure the peak value, it should be assumed that it indicates the RMS value.
If the RMS value is known, the peak value can be determined by multiplying it by 1.414. Assume that an AC voltmeter indicates a value of 120 volts. To determine the peak value, multiply 120 by 1.414. The waveform has a peak value of 169.68 volts. Another common value is called the average value. The average value is actually a direct current value. Oftentimes, alternating current is converted to direct current with a device called a rectifier. A bridge-type rectifier will convert both the positive and negative halves of the AC waveform into direct current. This is called full-wave rectification. Full-wave rectification produces a pulsating waveform. Notice that the voltage does turn on and off, but it never reverses polarity. Since the voltage turns on and off, the voltage applied to the load will be the average of the maximum value and the value at different times during the waveform. The correction factor to determine the average value is 0.637 of peak. Assume that an AC voltage with a peak value of 100 volts is rectified to DC with a bridge rectifier. The DC voltage applied to the load can be determined by multiplying the peak value of the waveform by 0.637. 100 times 0.637 equals 63.7 volts. A chart giving the multiplication factors for determining peak, RMS, and average values is given in Appendix D of Del Mar's Standard Textbook of Electricity.